Thank you for choosing our Patio Heat channel. I'm Steve. We provide tips and information to extend the enjoyment of your patio project. Our videos give you a knowledgeable overview prior to investing in your outdoor heating equipment. Whether you are a professional or owner-builder, we provide specific details for optimum heat coverage for your application. Post a comment or question, or for developed visual designs, send your request into designs@patioheat.com. We're here to work with you. For over 30 years, patio heating is the bedrock of our business, expressing what works best. Now let's get heating. All right, so here we have this residential patio deck cover, and we're going to go ahead and go right into the overall dimensions. So overall dimensions, I have 23 feet 2 inches from this point here to this point here. And then I have a section here of 18 feet from the wall of the structure to the outside edge over here. I have a height of the bottom of this beam at 8 feet, this beam here, 8 feet off the finished floor. And then I have the top at 9 feet. And then you can see I have the rooftop at the bottom edge of the ceiling here at 11 foot 10 3/4. Now the slope I have is 3 to 12, so for every 3 inches, 12 inches, every 12 inches I should say, 3 inches higher. And we can see we have some fans, or a fan. We have a TV set over here. There's a sliding door I believe over here, and some recessed lighting fixtures here and over here. There's going to be a couple of different seating arrangements. We have dining space over here, and then we have reclining space over here next to the TV section over here. Now, first of all, the request came in with showing how they had anticipated the heaters to be located, and what I'm showing right now is what they had here. So they have a 6,000 watt over here, 6,000 watt over here, and then one on this side over here. And I placed them centered within the structure itself. So from the center point here, I have them at 30 degrees tilt. And also one thing that I don't have is the true clearance, or the proper clearance. When they are mounted on a vertical surface like this, you need to have a minimum of 12 inches of clearance. If I was to show what a 12-inch distance would be, it's going to be something like this, where this is 12 inches here, and you can see that we are not meeting the clearance to the structure itself. So that is a problem with this particular unit over here. We are way up over here, plus the beam over here is clearance to combustibles that we have to meet. So this physical heater right here would have to come down. If I was to move it down to the point of proper clearance, it would be something like this, and obviously that would not function properly unless you change this bracket or altered it in some way so that it didn't look like this. But that would be the only way you can actually put this particular unit in this way. Let's go ahead and look at the footprint of heat on something like this. This is another reason why I don't really like this particular layout. We're heating most of the middle area over here, obviously, and that's not the seating positions at all. So yes, we're warming up these chairs here. These chairs over here are being warmed up over here. We could probably move this, if that's the case, that we're going to actually move it in a little bit further. But in any case, yes, it would heat up this space here, but only this space over here for this seating position over here. So let's go ahead and look at another option which I might recommend, and that would be the placing 4 units. Let's see here. Placing 4 units along the structure this way. Again, we need to make sure that we're meeting that 12 inches of clearance on the low side of the ceiling over here. And if I was to measure out what I physically have, let's go ahead and just put a line over here just to do that again. So if we went 12 inches, that would be the clearance section. Sorry for the movement like that, but you can see that physically here, looks like we are 1/4 inch off, so we'd have to drop it 1/4 inch, and that would be true on all 4 units. However, we could move the heater to the inside direction. So if I was to go like this and just move it maybe 2 inches to the right here, that would be enough to offset that clearance, most likely, if my slope is correct. So but in any case, I have this at a distance of, let's go ahead and mark that down as well. Let's make sure I get the center point of the heater itself. And we'll go over here. And you can see I have them at 11 feet 7 inches. Normally I keep them a little bit closer together, but we're not really focused on heating the center of the patio. So this would be adequate in my for my recommendation in this particular layout here. So that's these 2 units here, and then I have 2 units over here. These are all 6,000 watt units at a 30-degree tilt. And again, that 12-inch clearance is a necessity for the lower side of the ceiling. Let's go ahead and look at the footprint of heat, and you can see here that we are heating up this area very, very well. This would be something that would work out terrific, and you could use 2 different zones if you wanted to use a controller, or you can independently switch each one of these units on and off. I'm going to take off this measurement here. Yeah, definitely this would be something that would work in this application just fine. Let's go ahead and just look at what it would look like from a point of view like this. You're not going to see the footprint of heat or the ray itself, but you would see the heaters, and you're not going to see the ones on this back edge over here. That's what you would see here for the most part. All right, so that is a second option. And then let's go ahead and look at the last option, which would be something like this, having 4 of the units placed on the ceiling, but you'd have to have a drop for these particular brackets. Let's just say that this bracket here was to be mounted on the ceiling. You could make a custom bracket distance that would just be a piece of stainless steel, let's say. And that could be an extended piece that comes down to here, and that would give you the proper elevation and make sure that your heater is level. These heaters have to be level, otherwise the elements inside, as they heat up, they expand, and as they cool off, they contract. If they are on a slope, that will cause it to drop and then kind of overheat on the lower side, and then eventually just within a few weeks of use cause the unit to fail completely. So you want to make sure that you have them level like this. And let's go ahead and look at the footprint of heat on an application like this. You can see that the reason I kind of like this a little bit better is the fact that the layout is all uniform throughout the whole entire span here. And when you have it the other direction, like I showed before, which was like this, you have a hot section over here, a cooler section over here, and then a double heat section over here. And well, this works out well, and I just like the other option that I just showed here, which is kind of my preferred, where it's all uniform and unique. You can see this is infrared light waves, so if you're familiar with infrared light waves, I'm going to go ahead and just turn on the sunlight here. You can see if you were standing here in the shadow of the structure itself, you would not feel the sunlight itself, but if you were standing right here, you would feel that sunlight, and it would be much warmer, even though the air temperature around this whole location is all going to be the same. And that's the same thing with infrared light waves. If you're in the ray, you'll feel the ray. If you're outside of the ray, you will not feel the warmth of the infrared light waves. But they are light waves, and so they do bend and stretch. And so the footprint that I'm showing here is the ideal footprint. But there is more rays that come out a little bit further, and those rays will overlap right here. So this would be a more even amount of heat. Let's go ahead and show what the true distances I have on these. 8 feet center to center. And then also I just want to kind of quickly mention the clearances around the heater. So this is the lower clearance. You have 36 inches down below it and 18 inches on all 4 sides. And this is below the heater itself, so below the section here. And then if I was to show the clearance above the heater, it's 6 inches on all 4 sides and 6 inches from the top here to any combustible material above it as well. Let's see if there's anything else I wanted to mention. You can see that the layout with the light fixtures would be no problem, as well as the fan. Even if the fan was dropped here, probably would be. There is no issue with regards to the clearances above or below. If I was just to move this down, let's just go ahead and kind of show that maybe a 18 inches lower. You can see that we're pretty well cleared of any combustible material. Now I'm not sure about what the true dimension of the fan is going to be. Let's go ahead and just see what the dimension is that I have. So what I have here physically, this is going to be 4 feet 4 inches total in diameter, just so you know that. And yeah, so with that size of fan, that should be no problem with regards to the clearances themselves. So all right, well, I hope this has helped. If you're looking for some assistance with your outdoor heating application and you would like us to review your plans, send your information into designs@patioheat.com. And please ask any questions, make a comment, and subscribe to our channel. That really helps us out. We're here to help. Thank you very much. Have an excellent day.